In this nugget, you and I get to configure and set up DNS on a Windows 2012 server. We'll also take a look from a client perspective at some tools we can use, such as ipconfig and NSLookup, to verify and make sure it's working. Now, in this nugget, I would strongly encourage you, if you have a Windows platform to practice with, I would encourage you practicing alongside with me as we go through this nugget together. So as I use a tool, for example, ipconfig or NSLookup, I'd like you to pause the nugget, practice those commands, and get the hands-on practice during this nugget as we go through it together. Let's begin. So I want to walk you through what it looks like, just a little sample of configuring DNS on an internal Windows 2012 server. Then we'll take a look at Bob's computer, which is computer number 2 here, and we'll verify on Bob's computer using ipconfig, and we'll verify whether or not it has a DNS server that it can use. And I'd also like to show you some really sweet tools with ipconfig where we can actually see the DNS cache on the local computer regarding names it's previously resolved. And if we're troubleshooting, how we can also use ipconfig to clear on Bob's computer that DNS cached information. So we're sitting in a Windows 2012 server, and we've got Server Manager running from here. If we want to configure DNS, we can go to Tools, and then from the drop down, go down to DNS. And from here, if we wanted to create some new records for DNS, we could go to one of our existing zones. For example, here in my configuration, I've got acme.com, I've got nuglab.local, or we could right-click and have the option to create a new zone as well. So let's use our existing acme.com. We have several A records already here. If we wanted to add new records, we could simply right-click. From here, we could select from the drop-down, hey, I want to create an A record, which would be for IP version 4, or a quad A record, which would be for IP version 6. There's an option for a CNAME, which we know is an alias for another DNS name. There's the mail exchange. So as an example, let's create a new A record here in acme.com. So let's create an entry called sample. It automatically puts in acme.com down below because that's the zone I'm currently configuring it for. And let's give it the IP address of 23.1.2.98. And we could click on Add Host. We could also click this checkbox, and that would create the pointer record that's used for reverse lookups as well at the same time. So if we click on Add Host, we get a message saying it was successfully created. That's great. We'll click OK. We'll click Done. And there's our sample A record of 23.1.2.98, which resolves to sample.acme.com. So on this DNS server that I'm currently sitting at, it's using itself as a DNS server. So if we opened up a command prompt by clicking on the Windows icon, typing in CMD, and pressing enter, if we try to do a ping out to sample.acme.com, oh, I wasn't expecting the ping to be successful, but let's take a look at what happened. So we did our ping to sample.acme.com. In the background, this computer did a DNS request to itself, which is the DNS server, and said, hey, what's the IP address for sample.acme.com? The result was 23.1.2.98. Now, here's the funny part, and why I'm laughing. Because that's a real IP address that's reachable on the internet, and this computer has access to the internet, it then said, great, I'm going to start pinging 23.1.2.98. And it just so happened I got some responses back from 23.1.2.98. And not every device on the internet is allowing ping requests to be responded to. However, we lucked out, this guy is. But our whole purpose here was just to verify that the name resolution that I created on this DNS server was correctly working, meaning it was resolving the name to an IP address. And just for grins, if we went back in and we edited the properties of that entry and we changed the IP address to 8.8.8.8, which is one of Google's DNS servers, and we clicked on OK. And then if we go back to the command prompt and we hit the up arrow key and go to sample.acme.com, from here it's pinging the same IP address. Why is that? And the answer is my local computer. This computer right here is caching that information. It's not checking with DNS anymore. So right here, because we have the problem of this cached information on this computer right now, let me show you right now with the IP config tool how we can view and also clear the cached information on this local computer. So let's start off with the command ipconfig /display DNS. So ipconfig /display DNS and press enter. It's going to show us all of the cached information regarding DNS resolution that this computer currently has. And if we scroll down here, check this out. We have this cached information for sample.acme.com. And it's being resolved to 23.1.2.98. So even though that DNS record has changed inside of DNS, from a client perspective, the client has cached that and is still using the old information. So if we want to flush that old information, here's what we do. We're going to type in ipconfig once more, but this time we're going to use a slash and the command flush DNS. And we'll press enter. Now, if you get a message indicating, hey, you can't do that, you're not an administrator, what you'd want to do is launch the command prompt as administrator. And the way you launch an application as administrator is you can right click on it, go to the command, right click again, and then say run as administrator. And in a corporate environment, it's very likely that the average user is not going to have permissions at the administrative level for working with the computer they're sitting in front of. But if you do, this is how you could run the command prompt as administrator. So now that we've flushed the local cache on this computer with ipconfig /flush DNS, I'm going to press the up arrow key a couple times, and let's do the ipconfig /display DNS one more time. And now it's reporting nothing here because there's nothing currently in the cache. So let's do our ping again. We'll ping sample.acme.com, but this time, because we're making a DNS request, the answer should come back as 8.8.8.8. Now, if you happen to try this from whatever computer you're at and you don't get a response back, it doesn't mean that Google's DNS server was unwilling to respond back to us. It could mean that between you right now and the target of 8.8.8.8, there could be some device, such as a firewall, that is not allowing the ping requests going out or allowing the replies to come back. Those are both required, the request and the reply, to have a successful ping. This time it resolved to 8888. That's now in our cache locally on this computer. And then we did our business with our ping requests out to 8.8.8.8. Next, let's make a road trip out to Bob's computer, which is computer number 2. So here we're sitting in front of a Windows 8.1 enterprise computer. It's Bob's computer, computer number 2 in our topology. And let's bring up a command prompt. And my question is, how would we verify whether or not we have been configured to use a DNS server? How do we find that out from the command prompt? And if you're saying, Keith, it's ipconfig, I think that's a great start. So let's try it. ipconfig, we'll press enter, and ipconfig reports that we have an IP address of 10.1.0.101. There's our default gateway of 10.1.0.1, and that's R1's interface address. So we can use R1 as a default gateway. But you'll notice with the basic ipconfig command, it doesn't tell us the details regarding a DNS server or information about the lease time if it is a DHCP address. So to see additional information, we'll use the up arrow key and we'll add on the /all. And that will give us a more detailed view from the output of ipconfig. So now here with the output of ipconfig/all, we have additional information. Look at that. Here we have the layer 2 address of the network interface card. That's fantastic. It's also indicating that DHCP is enabled, meaning we're a client. There's the IP address that we're using. Here's our DHCP server, which also happens to be our router. That's why it also shows up as our default gateway. And ta-da! There's our DNS server that we've been configured to use. That 8.8.8.8 was advertised to us as an option as part of the DHCP exchange. So my next question would be, how do we determine what DNS cached entries are local on Bob's computer right here? And if you're saying, Keith, once again, it's ipconfig on a Windows computer, you'd be absolutely right. But the question is, what is the option that we need to add in conjunction with ipconfig to see that DNS cached information? And as I recall, it is display DNS, just like that. So ipconfig /display DNS, we'll press enter. And at the moment, we have nothing in the cache. So I wonder what it would take to put some entries in the cache. Just for a moment, I'm going to open up Internet Explorer just for a moment, and then I'm going to go ahead and close it. Now, that was just a brief opening and closing of that browser. Do you suppose DNS happened during that time? And the answer is yes. If the page came up and it was giving us current information, absolutely, DNS was resolving a bunch of names to IP addresses for us in the background. So if we use the up arrow key here and do the ipconfig /display DNS again, check this out. It is pages and pages and pages and pages of name resolution that's been done for all of those various objects that we were getting just from going to the default homepage for Internet Explorer. So from the top of the list, there's Bing.com, there's Microsoft.com, there's Chartbeat.net, there's MSN.com, there's Facebook.com, and all of that was just by opening the default homepage for Internet Explorer. So there were dozens of DNS requests and replies that happened all in the background in order to connect to and populate the web page that we're looking at. So if we wanted to flush that information, we'd use ipconfig /flush DNS, press enter, hit the up arrow key a couple of times to do a display, and now they're all gone. The other tool I wanted to share with you right here is NSLookup. And to use it, you can simply type in NSLookup, and you could press enter here, which would put us into interactive mode with NSLookup, or we could just go ahead and use it followed by a name. So if we wanted to know, for example, what is the IP address or IP addresses associated with www.google.com, we can simply type in NSLookup, put in that name, and then press enter. So there's the command we used. There's the DNS server that we're currently using. There's the name of our DNS server that we're currently using. That's the name we were looking for, www.google.com, and it gave us back a whole bunch of information. It gave us back a quad A record right here, which on Bob's computer, he's not using IPv6, so he doesn't really need it, but it did come back. And Bob has also received a whole bunch of A records. If we want to use NSLookup in interactive mode, we simply type in NSLookup and press enter. And now it's like a game of chess. NSLookup says, okay, great. I'm connected and I'm using DNS server 8888. That's the name of the DNS server. Your move. What do you want to do? So the end user, in this case Bob or us sitting at this computer, we could type in, for example, google.com. And it knows that, oh, you want me to resolve google.com into IP addresses. And we'll press enter. So here it did the resolution. It resolved google.com to this IPv6 address, this quad A record, as well as all these A records. And it left us at the interactive prompt saying, hey, what else you got? And like most interactive systems, there is some help available. We can issue a question mark, press enter, and that will give us the help regarding possible syntax that we could use. Let me make this a little bit bigger. So we typed in the question mark, and then we got a boatload of possible options that we could use. One I'd like to demonstrate is the type. If we were looking for a certain type of record, whether it's an A record or quad A, we could actually set the type that we're looking for here in interactive mode with NSLOOKUP and then issue our requests. So for the first example, let's set the type to be an A record. So the syntax is set space TYPE equal A, meaning I want to see the A records. And we'll press enter. So NSLOOKUP took that command and said, okay, great, I understand what you want to do. Your turn. Next, we're going to feed it the question, the name of what we want the A records for. And let's once again use google.com and press enter. Now you'll notice in the response that came back, it did not bother giving us the quad A records anymore. It only gave us the A records, and that's because we set type to A right here. If we wanted to get just the IPv6 quad A records, we could go ahead and use the up arrow key a couple times and set the type to quad A, set space type equal AAAA, press enter, and then we'll use the up arrow key a couple times to do google.com, and now we're just getting a response back regarding the IPv6 address, the quad A record in DNS. We could do the same thing for looking for mail exchange records. So if we type in MX for the type, press enter, then a couple up arrows, look for google.com again. It'll give us information regarding MX records. So for an email server, and now we know what the email servers are for google.com, we could then do further resolution of each of those names to find out the IP addresses for each of those servers. And let's do that. Let's go ahead and set the type back to A. So we're using set space type equals A. And let's go ahead and just grab one of these servers. So the A record associated with this entry right here maps out to this specific IP address. And to DNS, we simply say, thank you. And for one last example, let's do this. Let's set the type that we're looking for as a pointer record. That's going to be for reverse lookup. And for a reverse lookup, that's when we're specifying an IP address and we want to know the name associated with it, which is reverse from what we normally do. Normally, we do the forward lookup, which is here's a name, what's the IP address? So in this example, looking for a pointer record, we'll type in 8.8.8.8, which is a Google DNS server IP address. Press enter, and it comes back and says the name is google-public-dns-a.google.com. And that is thanks to the pointer record in DNS that allowed that reverse lookup to happen. Now, what I did not tell you, but I'm excited to share with you now, is that I also did some packet captures on this link before we started practicing with NSLOOKUP. And that way we can use a protocol analyzer, such as Wireshark, to take a detailed look at those packets just to reinforce the concept of the DNS and the types of records that we're requesting via the DNS. So here in Wireshark, in the protocol analyzer, here's in packet number 33. We've got a packet that's being sourced from 10.1.0.101, that's Bob's computer, and destined to 8.8.8.8, which is Google's DNS server, and it's a DNS query. If we look at the details for that packet down here, under the query section it says we're looking for google.com and we would like an A record, please. This protocol analyzer is also telling us right here that in the very next packet, packet number 34, it has the answer from that DNS server to display. So if we go down to packet 34 and select it, packet 34 is the response that's coming from 8.8.8.8 back to our client at 10.1.0.101. It's a DNS response. And in the payload it says you were asking for google.com, you wanted an A record. And regarding answers, I've got a whole bunch of A records here, IPv4 addresses that are associated with google.com. So Bob's computer may say, which one do I use? So then it would be up to the browser and the computer that Bob's using to decide which of those IP addresses Bob's computer is going to use. He doesn't need to use all of them, he just needs one. And then if we take a look at our next packet here, packet 35, this is when we're using NSLOOKUP asking for a quad A record. So this is Bob's computer asking for google.com and asking for a quad record here in packet 35. And the answer to that is in packet 36. So here in packet 36, the response coming back from the DNS server is that google.com is at this wacky IP address. It's not too wacky. It's simply an IPv6 address that's represented in hexadecimal as opposed to decimal. I'd also like to show you what an example of dynamic DNS looks like. For example, I have this URL here, http://cbt.gg/Keith Barker. And that's courtesy of Bitly. And that maps over to another name, which maps over to my camera, which, by the way, I've just turned on. So if we go to this URL and press enter, in the background it's doing all the mapping. There's some CNAMEs involved as well. And when I record, I turn this camera on so people can watch and see what it's like a day in the office of Keith Barker. Let me show you something really cool. These lights I have, my good friend Anthony Sequeira told me about this product called Hue, where you can change your light source. So this is my Nugget recording light. This is a reading light. And I've got, this is called Pencils. This is called Deep Sea. This is called Feed Up. So you can adjust the lights and it's all remotely controlled. Pretty amazing stuff. Or I could turn them off and then the camera would have to adjust to that light. So I'll put it back at my Nugget recording light set. And that's an example of how my lighting system works, but more importantly, it's an example of how dynamic DNS can keep track of this camera. Because even if my public IP address changes, my IP camera is reporting in the new IP address so that when people go to the URL, they can get the correct name to IP mapping due to dynamic DNS doing its work in the background. Let me give you an example of my home router that also supports dynamic DNS. So I'm logged into my local router at my home, and there's my public IP address right there, which won't be the same address next week or next month because it could change. So I'm not too worried about masking that out. If I click on Go right here for dynamic DNS, it's going to take me to the dynamic DNS settings page. And from here, for dynamic DNS, I can say yes, I want to enable it. And then I could use a third-party dynamic DNS service, such as dyndns.com or one of the other hundreds that are out there. And so what would happen if I set up my router to participate doing dynamic DNS, the software on this router would do the reporting to the dynamic DNS server to constantly keep it updated with the correct information regarding the IP address, the globally routable IP address that's associated with this router on the internet. In this nugget, we've taken a look at how to configure DNS on a Windows 2012 server. We've also looked at some command line tools on a Windows platform, including ipconfig and NSLOOKUP, that can assist us in testing and verifying that DNS is working. I've had a blast in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.